Hi, I'm Jeff Mucklin, and this is Science at Home, which is brought to you by the Nurture Nature Center. Today I want to talk to you about the science of fireworks. So let's get this episode off with a bang. Now, before we get any further, I should stress that you should not replicate any of the experiments that I am about to perform. If you want to see fireworks, the best way to do that is to see a professional fireworks show. Anyone igniting their own fireworks should do so with caution and in accordance with local law and in a way that is respectful to others. So the science of fireworks is really all about the science of combustion. There are many fuels that will combust or burn. Wood will burn, but it wouldn't make a very good fuel in fireworks because it burns very slowly. But when wood burns, it undergoes a chemical change that releases energy in the form of heat and light and gases. A piece of wood will burn relatively slowly, partly because fire consumes oxygen, and if the source of oxygen is just the air around us, there isn't enough for the fuel to burn very quickly. If I let the air out of this balloon by poking a small hole in it in a place where there isn't a lot of tension so that it doesn't pop suddenly, I release the potential energy in the balloon, but I'm doing it slowly, and so the result isn't very exciting. In a fountain or rocket, we burn a fuel that produces its own oxygen as it burns. This extra oxygen allows the chemical reaction to occur very quickly. Combustion releases energy in our fuel, and we get a lot of sound and light and gas very fast. In a fountain or rocket, all the energy is allowed to escape through a narrow opening, and we either get a beautiful pyrotechnic effect or we get a powerful rocket motor. This is equivalent to letting go of our balloon and releasing all of the energy very quickly. In an explosive firework, we burn that same fuel that releases oxygen, like for the rocket or fountain, but this time we don't provide an opening for the hot gases to escape. Instead, the fuel is put into a container of some kind. Typically a paper tube is used. As the fuel burns, the hot expanding gases travel through the tube, and in a very short time, heat and pressure builds up until the paper tube can't contain it anymore. The hot gases are released suddenly, and we get a loud bang. This is like popping our balloon. For some explosive gas mixtures, the fuel can burn so quickly that it doesn't need to be held in a container to produce an explosion. That's how these bang sight cannons work, like the one I showed you at the start of the video. This has an open end, but it has an explosive gas mixture that burns so fast it doesn't matter that it's open, it still produces a very loud explosive bang. Notice how different the effect was between releasing the air slowly, quickly, or instantaneously in our balloon, even though it was the same amount of energy being released each time. This is very similar how pyrotechnicians, these are people that design fireworks, this is very similar to how they control the rate of burning fuels to produce different effects. Many fireworks produce colorful lights as they burn. This effect is achieved by adding things to our fuel. Many colors are created by adding metals or metal salts to our fuel. This works because every element produces light when heated, and different elements release different kinds of light. Here's one of the pennies that we used in a video about horseshoe crabs. It's covered in copper salts. You'll notice some green coming out of the flame. This is because the copper is being heated and it is picking up energy as it gets warm, and as it releases that energy, it radiates photons. And it radiates photons of a very specific wavelength. This is how we give fireworks their color, by adding materials like this to them. I've poured a small quantity of black powder. It's not in a confined space, so it will not explode, but it will burn very rapidly and produce some light. Notice it's yellowish orange, and it looks a lot like any other fire that you may have seen. Now we have more powder, but this time we have added barium, which produces a lovely green light in the heat of combustion. Barium is also used in high-temperature superconductors, a topic we might cover in a future video. Here we see powder with copper flakes added, creating a brilliant blue light. Copper is also a very valuable metal that conducts heat and electricity very efficiently. It's also one of the first metals used by early humans. This dazzling yellow comes from sodium. Sodium is present in sodium chloride, which you might know as common table salt. It's also used in sodium vapor lamps, which line city streets across the world and produce the same yellowish light when heated by electricity. By adding calcium, we can produce orange light. Calcium is in our food and it's necessary to build strong bones. Here we see the dramatic red glow produced by adding strontium to our powder. Strontium is chemically similar to calcium and can also be taken up in bones. Finally, we see this royal-looking purple light, which is produced by adding strontium and copper. The red and blue light appear as purple to the human brain. We can even get golden light by adding iron. Iron is the most widely used metal by humans today. And here we see bright white light created by adding powdered aluminum to our firework. Aluminum has many uses. It's used as aluminum foil, it's used to make lightweight parts for aircraft, and it is one of the main ingredients in sparklers. Pyrotechnicians use these elements and more and special arrangements of their explosive powders to create art and excitement using chemistry. I hope you enjoy watching fireworks displays even more now that you know some of the ways that they do it. Thanks for watching, and happy 4th of July.